The next application of operation amplifier is peak detector. When you are using a AC voltmeter or a multimeter for measuring the peak value of a sine wave, it will not give the peak value, but you are able to measure the RMS value of the sine wave. Once you are getting the RMS value, you will be able to calculate the peak value. But the non-sinusoidal waveforms such as sawtooth, triangular, pulse wave, etc., we cannot measure the peak value by using a AC voltmeter or something like that. So one possible solution to measure peak value of a non-sinusoidal waveform is a peak detector. And the peak detector we can make from using an op-amp. So it's one of the application of op-amp. You can use it as a peak detector. Here is the schematic diagram for a peak detector circuit obtained from a single op-amp. Suppose you want to measure the peak value of a square wave. This is the input what you are applying. It's a square wave here, V input. You want to measure the peak value plus Vp of a square wave. Now you are applying this input to the non-inverting terminal of the given op-amp. So non-inverting terminal of the op-amp, you are applying the square signal. Now as it is in the non-inverting configuration, of course your output also will be non-inverted output you will get. That is in the same phase. There is no phase change. So during the positive half cycle of the input, during the positive half cycle of the square wave, at pin number 6, your output also will be positive. Now, when a positive voltage comes at pin number 6, diode D1, see the positive is here, negative is here. So positive voltage comes at this point, the diode D1 will be forward biased. That means it is on. So that voltage will flow in this way to the capacitor and the capacitor will charge that. And you are taking output at this point, that is the voltage across the capacitor. So voltage across the capacitor will be the charging of the capacitor voltage. So it will charge to the peak value of your square wave. That is happening during the positive half cycle. Now see what happening during the negative half cycle. During the negative half cycle, output 6, pin number 6 will be negative. Diode D1 will be off or reverse biased. And diode D2 will be on. In that time, the capacitor will start discharging through the resistor RL. Now, the operation we will make in such a way that charging time is much lower than discharging time. I will explain one more time very clearly to you. So, during the positive half cycle, say here I am applying the positive voltage. During the positive half cycle, you are expecting your output voltage here will be positive. Now, this diode will be on. This diode will be on. And when this diode is on, it is offering a very small resistance. Say I am writing it as RD. A small resistance RD. I am not that familiar with writing this pen, that is the reason it coming like this. So a very small resistance RD. When it is on, the capacitor will charge the peak value. So the positive half cycle, now capacitor was initially 0, the capacitor will now charge to the peak value. So charge to the peak value, capacitor charging like this. And remember the charging of the capacitor, say I'll write it as TC, it is given as through this resistance, on resistance of the diode, that is RD into C. Remember that the period of the square wave is say T. The period of the square wave is say T. Now this is very much less than T by 10, that is 1 by 10 the period time only it will take to charge this. Now once it is charged completely, the next half cycle you will get the negative half. Now negative voltage when it comes here. So during the negative half cycle, now this diode D1 will be off because negative voltage will be coming here, diode will be off and this diode will be on, whatever negative voltage it will flow to the ground. Now the capacitor now starts, so initially your capacitor charged like this, now your capacitor should start discharging. So we will make the discharge time TD. TD is, we will make in such a way that it is much greater than the period 10 times the period, 10 times your period. So this is already I marked here, this is the period of the waveform. Now 10 times, that means 10 times this 10 times T, that much time it will take to discharge. So in the half duration, half T, it will take only very little discharge, it will not discharge much. By the time the next positive half cycle will come here, the capacitor, the diode will be on, capacitor will charge, it will again charge to the peak value. Again during the negative half cycle it's not discharging completely, only very less amount it will discharge. So the peak value will be maintained like this. So this is the peak value here will be maintained over here. Now I'll go back to the slide. That is the working of a peak detector. You can see this is the peak value, capacitor will charge, charge, discharge. The important point here is charging time is much larger than, smaller than discharging time. Discharging time is very high, so it is not able to discharge completely, only a very few amount of voltage will discharge. So the peak voltage will be maintained over there. See here, CRD, that is the charging time, it is much less than 1 T by 10. You know T by 10, whole period, this is T. T by 10 means 1 by 10 the period itself it will be charging. Discharging it will take very less time. It is equal to, discharging is over 10 times T. So in this T, this is T by 2. Half part will be T by 2 means 10 T when you are comparing it is very small. So it will discharge very small amount only. That is the charging and discharging time of a peak detector. Now RD is the forward resistance, that means on resistance of the diode. RL is the load resistance. Now this R is here used to protect the diode. R we are using to protect the op-amp and diode from excessive discharge current. Also this one will minimize the offset problem. Now the D2, this diode conducts during the negative half cycle of the input voltage. So it will prevent the op-amp from going to negative saturation. So that's the working of a peak detector. Thank you.